Okay, so you got two vector spaces. Now I'm giving you a preview of linear transformation so your brain starts working on it. I did that earlier with some of the stuff we did in the first week and a little of the stuff we did beyond that. Okay, so you got a vector space V. It might be R2 or R3, right? Or it might be some other vector space that's equivalent to some R space, right? R7, okay? And another space here, okay? In the example we just saw, we were mapping from R2 into R3, okay? No, that was our first example. Where is what we just did? Did I cover it up? Must have. Okay, here we're going from R3 to R3, right? These are vectors in R3, and we're getting a vector in R3. Okay? Okay, so in general, there are vectors that map to the zero vector over here. Okay? Now, if the transformation is defined by a square matrix that's non-singular, then only the zero vector maps to the zero vector. It's easy to show that if you just follow the steps. Okay? But in general, you could have some subspace over here, some set of vectors. And we call this the null space. And everything in the null space maps to zero. Okay? And this is a subspace. Because if one vector maps to zero and another vector maps to zero, then when you add those vectors, it's still going to map to zero. Okay? And that's simply because A times V1 plus V2 equals A times V1 plus A times V2. And if A times V1 is 0 and A times V2 is 0, then A times V1 plus V2 is going to be 0. Okay? And similarly, scalar multiples. So it's easy to show that this thing called the null space is a subspace. Okay? And then we have the image of the space V. That's the set of all the vectors that you actually get over here in W. And the reason I talk about this now is we just saw an example of a couple of vectors that you can add and don't get something in W, right? Well, if you set up a matrix a certain way, if the matrix is non-singular and V and W have the same dimension, then there are going to be vectors over here that aren't mapped by this thing, okay? Okay, so there's a little more to this, quite a bit more to this, and we kind of end the semester with this picture, which is why I show you. There's also the null space of the transpose. The transpose matrix goes from here back to here, okay? And the image of the transpose, and all kinds of things with matrices and transposes, okay? One thing I'll say is the number of vectors you need to span the null space nah, I'm not even going to say it. Okay. Go from there. I'm going to be assigning in chapter 4 basically sections 1 through 4. Okay? And I'm going to give you a fairly big assignment because you got a whole week to do it, even though I'm not going to be here. A lot of it will be maybe looking back at some of the things on the test, thinking of what happens if you actually translate these through the systems of equations and so forth. Okay? I think it'll benefit you. Okay? I might not get all that into the I've already got the problem solved, the problem set, okay? That's already there. There might be things related to the test that I have to get you by email. Okay, maybe tomorrow evening, maybe Saturday morning, okay? So, go from there, okay?